Hello friends, Mr. Burrell here. We're nearing the end of Unit 10, talking about solving quadratic equations. We've talked about a bunch of different methods for solving quadratic equations. We talked about the square root method. We talked about factoring and using the zero product property. And then we just finished talking about the discriminant. And now we're going to kind of wrap it all together and talk about the quadratic formula. First of all, talking about the quadratic formula with real solutions. So by the end of this lesson, these are the things that I hope you're able to do. I want you to be able to know what the quadratic formula is and be able to solve quadratic equations using the quadratic formula. So this is another method, the last method we're going to talk about for solving quadratic equations. So here are the methods we've discussed for solving quadratic functions so far. We talked about the square root method. If I have just the squared term and then like a numbered term, in this case I added 25 on both sides, got x squared equals 25, and then I would square root both sides in order to get x equals 5 or x equals negative 5. Those are my two solutions. I've also talked about the factoring method, where if I'm given something like this, x squared minus 5x plus 6, where I have an x squared, an x, and a numbered term, that I can factor it. So remember that I multiplied a times c, found two numbers that multiplied to make 6, and added up to negative 5. And we found those two numbers to be negative 2 and negative 3. Negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. I put that in factored form, x minus 2 times x minus 3, and then I set each of those equal to 0 and solved for x, which gave me 2 or 3. X equals 2 or x equals 3. That was the factoring method for solving quadratics. We also started calling those zeros. Those solutions I called zeros because I set them equal to 0. We also just finished discussing the discriminant, which helps us to determine how many and what types of solutions a quadratic function has. Does it have two solutions? Is it going to have one solution repeated twice? Are they going to be real solutions? Or are they going to be imaginary solutions? So now, spoiler alert, not every quadratic equation that we see can be solved in one of these ways. Not every quadratic function I'm going to give you can be factored. Not every single one of them can be solved using the square root method. So what do we do in those cases? A lot of time actually in the real world, quadratic equations are not going to factor out really nicely and perfectly. But there is a way to solve these kinds of quadratic equations. And that way is the quadratic formula. So the quadratic formula is a formula we can use to find the solutions to any and all quadratic equations, even the ones previously that we've discussed that could be factored or solved using the square root method. This formula can also solve those kinds of equations. So remembering, keeping in your brain that this is the standard form of a quadratic equation, ax squared plus bx plus c, all of that set equal to 0. Here is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, noting that like the a's, b's, and c's here coordinate with a, b, and c in the standard form of a quadratic function. So this kind of looks like a gnarly formula, right? You can see this little chunk probably looks familiar. This little chunk is the discriminant. This little chunk here is something we're going to talk about in the next unit called the axis of symmetry. There's kind of a lot going on. And if you're curious where this formula comes from, it takes more time to explain than I have in class to show you or in this video. But if you want, I can show you sometime. There's a video on the Canvas page with like a song that helps you remember this formula. But this is the quadratic formula. Post it on your forehead, write it in your rear view mirror, write it on your mirror at home. Get real familiar with it. We're going to be using it quite a bit. But again, don't be intimidated by this. Once we have this formula, it becomes really straightforward to plug in all our numbers in order to find my solutions. And again, if you're curious where this comes from, how it's derived, let me know. I will show you. So let's do an example. The instructions here are to solve each quadratic equation using the quadratic formula. So, before I solve this one using the quadratic formula, I'm actually going to solve this one by factoring, just as a little bit of review, because this one actually can be solved by factoring. So, notice that this is already in standard form. There's not a greatest common factor. So I'm going to go ahead and multiply A. Here's A, B, and C. A is 4, B is 9, C is negative 13. A times C, or 4 times negative 13, let me wait for my calculator to boot up, is negative 52. So I would need to find two numbers that multiply to make negative 52 and add up to 9. Okay? So I'd be going through here and I'd say, okay, 1 times negative 52, and negative 1 times positive 52, etc., etc. 2 times negative 26. 3 doesn't go into 52. 4 and negative 13, or negative 4 times positive 13. Those are going to be my two numbers. Negative 4 times 13 is negative 52. Negative 4 plus 13 is 9. So I would write my factors like so. X minus 4, x plus 13, and then divide both of these numbers by 4, because that's what A was. Reducing this fraction, I get x minus 1. This one doesn't reduce, so I'm going to go bottoms up, 4x plus 13. And this is all equal to 0. Then a couple lessons ago, we talked about the zero product property, so I would set both of these equal to 0. So here I would add 1 on both sides, and I would get x equals 1. Here I would subtract 13 on both sides, which gives me 4x equals negative 13. And then I would divide by 4 on both sides, which, let me get my little decimal here, negative 13 divided by 4 is negative 3.25. Those would be my two answers, 1 and negative 3.25. I was able to solve that quadratic by factoring. Okay? So, let me erase all this jazz. Now I'm going to show you how this same quadratic can be solved, and I'll get the same answers using this quadratic formula. Okay, this negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, it seems like a lot, but don't be intimidated by this. So, x equals, I'm going to start writing out this formula, filling in the a, b, and c spots with a, b, and c from this quadratic equation. So I'm going to write negative, and then I'm going to put b in parentheses, which is 9, plus or minus the square root of, parentheses, b squared, so 9 squared, minus 4 times a times c. So a is 4 and c is negative 13. All divided by 2, and then in parentheses a was 4. Whew! So that's the quadratic formula. I plugged in all those numbers just as I should in parentheses there. Okay? So what I'm going to do first is I'm going to type in my calculator the discriminant here. So what's underneath the square root. Okay? So I'm going to type in parentheses 9 squared, parentheses 9, close parentheses, squared, minus 4, and then in parentheses 4, and then in parentheses negative 13. So this is the discriminant. This is just that little part underneath the square root here. That is 289. So if I write this out, I'm going to have x equals, and then negative parentheses 9, that's just negative 9, plus or minus the square root of 289 over, and then 2 times 4, what's 2 times 4? That's 8. Okay? So this is going to give me two different problems. So notice this is x equals negative 9 plus or minus the square root of 289 divided by 8. So I'm going to write out two different equations here. X equals negative 9 plus the square root of 289 divided by 8. And x equals negative 9 minus the square root of 289 divided by 8. Okay? I have two different answers here, two different equations that I'm pulling up. So, I'm going to go ahead in my calculator. I'm going to type in negative 9 plus the square root of 289, enter, and then divide by 8. So that first answer there is 1. This all came out to be 1. That's one of my answers. So then pulling this up again, I need to do the exact same thing, negative 9 and minus the square root of 289, enter, divided by 8, enter, I get negative 3.25. So this comes out to be negative 3.25. My two answers are 1 and negative 3.25. Well, look at that! I got the same answers as I did by factoring. 1 and negative 3.25. So those are my two solutions. Those are my two zeros. 1 and negative 3.25. If I was looking at a graph, that would be where I cross the x-axis at 1 and negative 3.25. So again, the quadratic formula can be used to solve all these different kinds of quadratic equations. Not just the ones that can be factored, but all the ones that any kind of quadratic equation I'll give you. Okay, I'm going to skip this one. I'm going to come to one of these ones. Let's do a couple more examples. So this is solve each quadratic equation using the quadratic formula. Let me write it back up here so you can have it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Get that in your brain. Get it up there. So here I have x squared equals 4 plus x. So first, this quadratic needs to be in standard form before I do anything. Is this quadratic in standard form? No, it's not. In order to be in standard form, everything needs to be on one side of the equal sign. So I want everything to be on this side of the equal sign over here. So I'm going to go ahead and subtract this 1x on both sides, which gives me x squared minus x equals 4. Then I'm also going to subtract 4 on both sides, which gives me x squared minus x minus 4 equals 0. So that's my quadratic equation. So what is A, B, and C in this case? Well, it looks like A is 1, B is negative 1, and C is negative 4. So let me write out the quadratic formula. X equals negative b, so negative and then in parentheses, negative 1, plus or minus the square root of b squared, negative 1, squared, minus 4 times a times c, or times 1 times negative 4, all over 2a, or 2 times 1. That's my quadratic formula. Again, I just plug in a, b, and c values for the a, b, and c values in the quadratic formula. So let's pull up my calculator again. I realize my face might have been in the way for a lot of those. That's fine. So let's see. I'm going to type in my calculator just what's underneath the square root here, the discriminant, this part right here, right? So I'm going to type in parentheses, negative 1, close parentheses, squared, minus 4, parentheses, 1, parentheses, negative 4. Making sure to put like the negative button instead of the minus button. So that's the discriminant. That gives me 17. 17 is what's underneath this square root here. So I'm going to go ahead and write x equals, and then negative times a negative 1, what is that? That's a positive 1. Plus or minus the square root of 17 divided by 2 times 1 is 2. So I've simplified a little bit. Now note I'm going to have two different answers. X equals 1 plus the square root of 17 divided by 2, and x equals 1 minus the square root of 17 divided by 2. Okay? So let me pull up my handy-dandy calculator. I'm going to do 1 plus the square root of 17, enter, divided by 2, enter, and I get 2.56. So this answer is 2.56. It's a really long decimal, which is fine. But that's one of my answers, 2.56. Let's see, my other answer is going to be 1 minus the square root of 17, which gives me that. Divide by 2 gives me negative 1.56. Negative 1.56. So those would be my two answers, 2.56 and negative 1.56. Okay, I'm going to leave this one up here for you guys to practice a little bit more. You can rewind the video and do this problem on the previous slide that we didn't do. You can try and do that one as well. But there's one more real-world type problem that I would like to solve with you, to give you another example as to some of the real-world types of problems that you can solve. So, this might be a question straight out of a physics textbook. So a person throws a ball from a height of 6 feet, so this person's 6 feet tall, with an initial vertical velocity, or initial speed, of 48 feet per second. That's how fast they throw this ball. Use the vertical motion model, h equals negative 16t squared plus vt plus s. So this is my quadratic equation for like throwing something up in the air, where v is the initial velocity in feet per second, and s is the starting height in feet, to calculate the amount of time the ball is in the air before it hits the ground again. Round your answer to the nearest tenth if necessary. So here am I, I'm 6 feet tall, right here. Optimistically, I'm 6 feet tall, I guess. And he throws this ball in the air. How long is it going to take to get back down? They give us the formula for it. Right here is h equals negative 16t squared plus vt plus s. Okay. And it says v is the initial velocity. So it told me that I throw the ball with an initial speed of 48 feet per second. So this v number is 48. And then it says s is the starting height in feet. Well, I started at a height of 6 feet. So this is going to be 6. It says how much time is the ball in the air before it hits the ground again? So what is the height when the ball hits the ground again? What is the height of the ground? Well, the height of the ground is 0. So, I have negative 16t squared plus 48t plus 6. I can solve this using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c match up with the same a, b, and c values here. So a would be negative 16, b would be 48, and c would be 6. And it's fine that like this first number is negative. The quadratic formula is going to take care of all of that for us. The quadratic formula is very forgiving, very nice. So, x equals, I'm going to go ahead and fill in my numbers here. Negative b, so negative 48, plus or minus the square root of b squared, so parentheses 48 squared, make this line longer, minus 4 times a times c, where a is negative 16, sorry that was so small, negative 16, and c is 6. All divided by 2a, or 2 times negative 16. Okay, let me pull up my handy-dandy calculator. Can you still see this if I... Yeah, it's close enough. So I'm going to type in the discriminant. Just what's underneath the square root here. This part right here, right? So I'm going to pull this up. So I'm going to have parentheses, 48 close parentheses squared, minus 4 parentheses a, which was negative 16, close parentheses, open parentheses, c, which was 6. And that gives me 2,688. Woo! So x equals negative times 48 is just negative 48, plus or minus the square root of, what was it again? 2,688. 2,688. All divided by, what's 2 times negative 16? That's negative 32. So, I'm going to have two answers here. X equals negative 48 plus the square root of 2,688 divided by negative 32. And x equals negative 48 minus the square root of 2,688 over negative 32. Okay? So let's type those in. I think I'm going to move my calculator over here. Let's see if it'll let me. Boom, right there. Okay, so negative 48 plus the square root of 2,688. What's that? 3.85, and then I'm dividing by negative 32. Divide by negative 32. That gives me negative 0.12. So let's see, let me go back here. Gives me negative 0.12. And then my other answer is going to be negative 48 minus the square root of 2,688. It's negative 99.85 something. Divided by negative 32. Gives me 3.12. So this is 3.12. And note that, like, the quadratic formula has a standard variable for x. We were actually solving for t, so really these should be t's. So the time it takes for this ball to go up in the air and come back down again is either negative 0.12 seconds or 3.12 seconds. And I'm not really going backwards in time, so that negative doesn't really make any sense. But it looks like it's going to take 3.12 seconds if I throw this ball from 6 feet up in the air, right here, up into the air and back down again. It's going to take 3.12 seconds to hit the ground. So that's one of the real-world examples that we'll see for using not only solving quadratic equations, but specifically the quadratic formula, because this is one that we couldn't solve using factoring. The numbers in the real world doesn't always work out that way. So this is one really good example where we can solve this kind of problem using the quadratic formula. So that's it. That's all I've got for you in this lesson. Hopefully you're able to know what the quadratic formula is. Again, ingrain this in your brain. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And hopefully now you feel a little bit more comfortable solving quadratic equations using this formula. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. I hope that you enjoyed that as much as I did.